Yeah, last slot of the day. I hope you all had amazing 2 days. I had, although I'm totally nervous, big crowd, English talk, more used to do them in German, but nevertheless. Thanks for coming. My talk has one of the longest titles, I guess. It's called Beyond Built-in Advanced Testing Techniques for Spring Boot Applications. Hi, I'm Michael. I'm a Java champion, which doesn't mean anything. So you probably know more than Java than me, but I'm so dumb and write about it, give talks, and do some public relations for free for the language, for the whole ecosystem. And I currently work as a senior consultant at InnoQ. We are a mid-sized German consultancy doing everything in the software space, from architecture, reviews, software development, some infrastructure stuff, nearly everything. And I don't know if you know, but usually you submit your talk pretty early and then you get accepted, and you normally just have an idea in mind and then you start preparing. And during my preparation, I found out the title is wrong. So the honest title would be Before and Beyond Built-in Advanced Testing Techniques, and so on and so on. Because during my projects, I often learn that people handle testing as a second case, not as a first case. So we all know testing is important, but many of us don't want to do it. We want to code, we want to solve the problem and not write tests. So this is like a little journey with some basic stuff that you may or may not know. And then at the later stage, we are diving into Spring Boot and things you can do with the provided stuff. And I forgot, if anybody has a question or wants to add a note, please just raise your hand. I try to remember to repeat your question or note, and we will find it, we will see if we can solve it directly. So don't wait till the end, please. So built-in. What's built-in in Spring Boot? So I think the most famous thing that comes with when you go to start.spring.io or write your POM from hand or whatever is you include the Spring Boot starter test. And then you have multiple batteries at hand. But what are these batteries? So first of all, so these are the dependencies of the Spring Boot starter test. Spring Boot starter test, yes. So they already picked some basic libraries that provide you with testing help. And they decided we want to come with JUnit Jupyter included, which is the long name for JUnit 5. Who has never seen a JUnit 5 test? Okay, perfect. And in the Java space, it's a little bit divided. So JUnit runs your test and has some assertion capabilities, as you know. But normally, most of the assertions we write are written in SJ or Hemcrest. Choose whatever flavor you like. There are a few more you could choose, but these both come with if you include the Spring Boot starter test. And then if you want to mock, you are not forced to. We could discuss more how to mock or not to mock, but that's not a topic for today. You can use Mockito for that. And if you have some concurrent code where your test does not know when the concurrent code has run, you can use awaitility. Did I pronounce it correct? Yes. Okay. And then there are some more utilities which come included, which is some stuff for asserting JSON. And if you happen to use XML nowadays, there's XML unit that comes with it too. So that are all the fundamental base libraries that you would use even outside of a Spring project. But there's another dependency, Spring Boot test itself. And Spring Boot test basically is a combination of the great testing support from Spring Framework, which is the foundation of Spring Boot, and some glue code that's built on top. And we'll see a little bit later. And every time a slide appears with some orange color, it's like a call to action, like maybe keep that in mind. That's the important points I want to emphasize. So please, please, please read the reference documentation if you're testing Spring Boot applications. And please read both reference documentations. The links are above and are clickable in the slides, which you can download. There's a link or a QR code at the end, and I think the presentation will be provided by the conference too. Because what I often, when I come into a project, people do tests, but they often don't know why it works or if it works, and many times my job is just providing the correct link to the documentation. It's everything in there, but we often forgot to read it, and even if you've written Spring and Java for multiple years, revisit it sometimes. Every time I revisit it, I learn something new. So there's many stuff in. Okay, so built-in batteries are all these libraries, and then there's some support for testing Spring stuff, and Spring Boot on top has some more. And as I said, we need to start before Spring if you want to test everything. And all starts with JUnit 5, so everyone here has at least seen or written a test. And maybe your test looks like that. And I mean, maybe it's personal opinion or preparations. This can be even simplified by using just new and throw away your setup blocks if you have simple setups. I mean, by default, JUnit creates one instance per test, and after this test, it throws away, creates a new instance, and uses that. So I personally find that more readable, and I don't know if everybody here knows that. So there's much more we could talk about JUnit, but not much time. So the next call to action. Please, please learn the basics. I know it's so easy. Start SpringIO, you got a project, you have even a working test that comes with. But Spring Boot is built on such a big foundation, so it's not enough to just learn Spring Boot. So please, if you have some time or fight for a little bit of time, learn the basics, revisit them from time to time. If you got the basics right, everything follows. And then JUnit has some more advanced stuff that you may or may not know. A highlight of mine is parameterized tests. For example, in this case, I want to test some isAdduled method on a person. And now I could write and test for is age 18, 21, 42, 77, 99, and 122. But repeatable test makes it so much easier. So you just have one test and an argument, and then you need some kind of source. And now JUnit basically generates one test for every value. So we have written 6 tests with one line and some method body. And now you can say, oh, that's such a basic case. Our tests are much more complex. We can't just provide one integer, of course. Yeah, but there's as I said, the source concept is even extensible. So there's a method source, and basically isAdduled with country examples is the name of the method below, and that returns a stream of arguments. And then you can pass multiple arguments. You can make it as complicated as you want. And so it's no excuse that you're not dealing just with plain simple types, because you can construct here whatever you want. There's even a trick for naming arguments if the value of the argument is not expressive enough. For example, if you pass in files or something like that. So that's one of the most used advanced stuff I use from JUnit, and I think everybody should use it when it's appropriate. And nowadays, I think if you use IntelliJ, at least in the Ultimate Edition, sometimes it tells me, here are 3 test cases that looks equal, please use parameterized tests. So, good idea. And then there's an extension model for JUnit, and that's even more advanced. For example, imagine you have some service that does some things, and in this case there's some logic, and based on that logic a log is written, and it may be an error or a warning, and it's mission critical for your application. I mean, we should not rely on logs, but we don't live in a perfect world, and I've seen cases where it was important for my customer if a log is error or warn. So maybe I should test that too, right? We should test all our code. And just imagine you could just add another argument to our test, which has some annotations, and then I can assert that these logs are written. And that's possible. You can implement it. So what is a JUnit extension? It normally starts with an annotation, the add extend with annotation, and then as an argument to that annotation, you give the actual extension, and you can meta annotate it as you could see here. So I could have put the add extend with logging extension directly on the class or at the argument, but I used that meta annotation logging. And the logging events is just a plain Java class that collects all the events, or the log event that happened, and you can use it to assert. And now the magic lies in the extension. And in this case, we need a parameter resolver, because the logging events is given as an argument to the test. And then you need to override supports parameter and resolve parameter, and that's just a basic example how to do it. You have some kind of store within your extension context where you can save and retrieve some objects if you need them at several points at the extension. And the second thing we need to do is we need to implement a second interface before test execution callback. So basically the extension does not only provide this parameter, it is run before every test, and there I set up all this appender, and with that there's a little bit of code left, but it's workable. You could implement that test. And if you look in the wild, there are multiple extensions outside. So the example basically is the JUnit 5 logging extension, with which I've written myself for some customer project. There's log collectors, which basically does the same, and I don't know why I re-implemented it by myself. Maybe I've not seen it, or I was forced, I don't know. And even if you do not use such stuff, there are at least one important extension, that's the Spring extension. So one part of the magic of all the Spring testing and Spring Boot testing is that Spring provides a JUnit extension which allows to combine the JUnit lifecycle with the application context. And Spring provides another extension, that's the output capture extension, where you can intercept all calls to system out. So you could even test system out stuff if you're writing an CLI application or such thing. So long story short, know some advanced stuff and some advanced features. I don't mean write an extension for everything, but there are certain cases where it could be useful for writing your own extensions, or at least looking if there is one in the wild. We did a little bit of setup stuff in the JUniter example, but here it's about our initial data we need to set up. Normally, I structure my tests after given, when, then, or what is it, arrange, act, assert, but you're free to do whatever you want. And then I maybe need to create a person, and I set the age to 18. And if I need to set multiple fields, that gets messy quite short, right? So maybe why not put every stuff into the constructor? But now I have to even fill out the fields and properties the test does not rely on. So for the total method, the name of a person should not matter, but I have to invent some name here. Normally you pick some value to make clear that it's not relevant, but that's not that easy. And if my person has 20 properties and just the age is important, I have to provide 19 things that don't matter. And for the reader who reads the test, it's not easy finding out which of these is important, right? So maybe we can use another pattern. I think Fowler called that the test mother, where you have known objects that represent some known person. For example, person's Michael. Maybe you don't want to use a constant, you want to use a factory method. So that someone changing the constant does not break other tests. I like it, but now everyone needs to know what are all the properties of Michael that are relevant for this test. So is he even an adult? I don't know. Sometimes I am, sometimes I'm not. And a solution I like then to use is basically a combination of the mother and the builder pattern. And we could say we want a person with age 18 build. So I only need to call the with methods that are relevant for that test. And now a reader can see, oh, that's important. And maybe we can add some randomness. So maybe it's enough to say we need a person that's older than 18. And I don't care if he's 18, 21 or whatever. Or maybe if you have more higher level tests, I just want to say a person that's an adult, because if the person is an adult, is checked somewhere else. So the test gets more and more and more expressive. And I've implemented these patterns in multiple ways in multiple projects. And for example, you can write this person's class, you have a person's builder, and in this builder you need to construct your person. And what I like to do is not use fixed values for the initial person. I use randomness. So if my total method would check if it's Michael, it says adult true, and I use a fixed name of Michael here, this test would succeed. But when I mix and match my values for every run, at every run, sometimes in the future the name must be another value, and then the test fails. And if you do that, keep in mind it's a good idea to print the seed with what the values are generated somewhere, so you can reproduce that case if it gets more and more complicated. And this one uses common slang, which produces a random alphabetic, produces random names. So maybe you need a library which is a little bit better, and one I found is Data Faker. So Data Faker has randomness, but knows the concepts of stuff. So for example, it knows a name and full names, and then there is a name randomly picked, a little bit like Docker images pick a random name by combining these two name lists, if you've seen that. And there are numbers, there are credit cards, quotes, career, I think there are programming languages, so they maintain a list of almost everything. I think countries, cities, streets. So you can use that to create random data which looks more realistically than just random strings. Another solution would be to use Instancio. Instancio combines a little bit this randomness with some builder pattern itself, but it does the same. Try it out maybe. And the last thing is, if you don't want to write all these builders yourself, there's even a solution for that. It's called Make It Easy. And there you could define properties and instantiators. And this value of that Michael and 42 are the default values, which I then would change to some random values. And then you could write your test setup with n person, though n is a static import of the library, person is the instantiator, and then you can say with, and so on and so on. So you don't have to write all the code itself. And I think there are much more libraries which you can find if you look for it. So keep your test code reasonable. Reasonable means make it easy for the reader to understand what's happening, and don't make your test setup too clumsy. I've seen tests where with hundreds of messages just for the setup, with set here, set there, and so on and so on. Assertions. We've already seen Spring Boot brings SJ and Hemcrest, and maybe some of your tests then looks like that. Assert that, get name is, get age is, get is adult at. You could argue a test should assert just one thing, but I mean, asserting one thing does not mean there should be only one assert call. It's a logical assert one thing. But nevertheless, you could optimize that. For example, in SJ, you could use extracting to extract all the three properties and then basically check a list of mixed objects. But is that readable? Maybe not. And so both frameworks, Hemcrest and SJ, have a way to write your own assertions. Please use that. If the more complex your business objects that you assert gets, the more important I think is it to have some values here and to do something like that. It's possible with both ones. So please keep your test code readable and not only reasonable. And then there's one special case, equals and hash code. I know we don't need to implement them ourselves. We can use records, we can use stuff like Lombok or something, but sometimes we have to implement it ourselves. And I think you all know what is required for equals to be valid. So it needs to be reflexive. So x equals x needs to be true. It needs to be symmetric, so if x equals y, y needs to equal x. It needs to be transitive, so x equals y and y equals z, x needs to equal that. And it needs to be consistent, so if you don't change any property in between, the same call must return the same result. And then there is a combination with hash code where equal objects need to have the same hash code. And of course we need to test that too, and we could write many code ourselves, but there's equals verifier which does everything for us. So by default it checks that every field, or it mutates every field and checks that all for us with just one line. Sorry, long day even for me. Yeah, and I've used that multiple times, and it's helpful. So that keep your test code maintainable too. So even test code or take care of your test code like it's production code. And if you use that library and don't write anything ourselves, we need to maintain less code ourselves. And yeah, if that external library is improved, our code's improved too. Okay. So we are through the before part. Now to the beyond. Spring Boot testing. Who has seen written or not seen written a test for Spring Boot yet? Okay, everybody has. So, short reminder. What does Spring Boot testing mean? Spring Boot testing primarily is or was a simple annotation. Well, I should not say simple, but adding that annotation is pretty simple, and what it does is very complex. But you can annotate your test with @Spring Boot test, and what's then done is, and that Spring extension I talked earlier about is registered, and that basically does the same than your main method. So it finds all your beans, assembles a complete application context, and now your test is more or less running within that application context. So you can let you inject beans with @AutoWire into your tests. You have the option to start even the web server, which by default is substituted by a mocked one. So no real HTTP traffic is going through, but it behaves like that would be. And because there's so much stuff, these tests tends to be slow, whatever slow, for certain values of slow. I mean, I've seen tests that run a few hours. In that comparison, Spring Boot test is pretty fast. But for our front-end people, Spring Boot tests are pretty slow. And because that's the case, these contexts are cached. Please look into the documentation if you're having some trouble, because there's a detailed explanation what is used for caching and reusing these. And don't mark everything with @dirtiest context, because that makes your tests even slower. And that allows testing your whole application. But before you do that, just think for a moment. Maybe you don't need your whole application context for the test. And I don't know when it was introduced, but nowadays there are these test slices. I think, who has not seen a test slice yet? Okay, okay, few. So there are multiple annotations that all end with test. The most known ones I would assume is web MVC test and all the data tests, especially the data JPA test. And what that does is it does not load the complete application context, it just loads a part of it. For example, the web MVC test only loads stuff annotated with controller or REST controller, some JSON related beans, maybe some web filters, but it would not load your repositories or your components or your services. And because it does that, it's normally faster than your Spring Boot test. I mean, there may be some outliers, but in general it's faster. And you can use that to just test that specific slice in isolation. I would call it integration testing, but wording may vary at your organization. But even before adding that annotations, maybe take a step and think, do I even need a slice of my application context? Especially for most of the business-related stuff, you maybe don't need any advice from Spring. You don't need dependency injection because you can inject your own objects. For testing business logic, in my opinion, it's the best idea to just use plain unit tests. And that's the reason why I included that before part. So if you don't need any feature of the container within your test, you can skip both ways. You can skip Spring Boot test, you can still skip some slice, so just write a plain unit test. It's so fast, faster than everything else. But then you need to mock, of course, your dependencies yourself, and I think you know that. So what to do if you don't want to write a plain unit test, you don't want a Spring Boot application test, and test slices doesn't match either. Then you have, in my opinion, you have three options available for extending what Spring Boot provides to write your own tests. So the first strategy, I call it extend here. And the example is, imagine you have a REST controller which prints the current time in a specific format. And we want to test it. So maybe our test looks like that. How often will that test be green? Probably never. If we are lucky, once. Yeah. So the problem is, let me step back, because I'm constructing there the now time. At the moment when it's called, I cannot manipulate time. And therefore, the most common pattern, of course, is I need something that can provide a time to me. And we are lucky because with the new Java Datetime API, there is already an extraction clock. If you started before, what Java was Java Datetime in? 11? Probably? 8? Yeah, or 8. But if your project started with 7, 6, or 5, you may have your own abstraction above of that. So what this allows is we can manipulate time within our test. And for that, we can provide our own test configuration, which constructs a clock with a fixed date. And because now we have two beans that are named clock, Spring Boot by default says you are not allowed to override other beans, and I need to set that property. I think what they are planning is like a test bean annotation, which could make that a little bit more comfortable. So problem solved, but now you need to do that for every test that relies on time, right? So what if we could just replace that whole setup with one annotation with local time, date and time? And you've already seen everything that's required for that. So let's write an interface with local datetime with our two properties, with the test property source, and that imports an auto configuration. That auto configuration provides us with a delegating clock. So that's more or less the same code you've seen in the test code. And then we need a second thing you've already seen. Yeah, we need our own JUnit extension for that. And in this case, we want a before each and after each callback. So this extension is called before and after each test method execution. And then I can find this local datetime annotation there, and if it's present, I can set the clock to before the test runs and reset the test as a clock after. And I think, that's possible because the Spring extension itself stores the application context within that JUnit store, and therefore I can get to the application context, can take my bean out of it, and because I have my own implementation of a clock, I can replace that clock. So I call it extend because you are adding basically all the stuff you are defining here to your test on top. So my test is a web MVC test, but uses that too. Okay. So second strategy, I call it, or when I created the slide, I thought about that's stuff like composing. So imagine, and that's basically a problem we had in one of our projects in the real life, you have some very complicated migrations for your database. So what this does is it adds two columns to a table, first name and last name, and that table had a name column before. And now I want to split the name to pre-fill first name and last name. And of course, that does not work with most of the names out in the world because that's made up. But we had very complex migrations. And when I read it, do I know if it works? No, I don't know. So I have to test this too. And what we came up with was we composed some stuff and created the concept of a migration test. So this migration test tests the migration from version 1 to 2, that's stated in the annotation. And then we are using a JDBC template. And what this compose extension adds is that migration test template, which we can get as an argument. And then I can specify before the migration to 2, please truncate my table, and we insert a single record as a test entity. And in the template after the migration to 2, we want to assert that this has worked by selecting from the table and then seeing that the data that comes out is correct. And to be honest, when I put that on the slide, this before migration, after migration with callbacks thing may not be the best API I've come up with, but it was there at the time. And so what can we do to compose it? Compose it because we know every time we want to test that migration, we don't need that in combination with another annotation like web MVC test or such stuff. And therefore we compose it by saying every test that is annotated with migration test is a Spring Boot test. We don't want the flyway auto configuration of Spring Boot to run because we keep track of the migrations ourselves, so we customize the Spring Boot test a little bit. And then we need JUnit extension again. And in this time it has some before and after each callback to drop all the tables because the migration needs to create it itself. And afterwards we want to replace it with the data of before. And then we again need a parameter resolver which provides us with this migration test template that needs access to the data source, which we can extract out of the application context, like we did with the clock in the example before. And then this migration test template is just plain Java code, which uses flyway under the hood directly to run the migrations. And we used that to test multiple migrations there, and it worked. And maybe you come up with such things for your own projects. And then there is the ultimate weapon or power, create. So there's Spring Boot test, there's the test slices. Maybe you come up with some cases where you should create your own slice. And that's possible too. As an example, and that was before Spring Boot 3.2 introduced that connection detail stuff and made it easy to connect your application to test containers. We wrote our own test slice, which was a Postgres repository test. So it was a test where you can test your repositories against a test container that starts Postgres. And at that time, it wasn't that easy because you had to do much stuff yourself. And so everything starts again with that annotation, Postgres repository test. And we have some two properties, repositories and value. And this alias for just means you can use either value or repositories. Value allows you to not write repositories equal to. I think you all know that. So what's next? A test slice usually is a Spring extension or needs a Spring extension because we need access to the application context. So we add that. And then we want our test to be bootstrapped with a Spring Boot test context bootstrapper. What that does is that knows how a Spring Boot app is assembled. So it knows about all that conventions of a Spring Boot application, and that basically loads the application context by default. And this one uses type exclude filters to control whether a bean should be loaded or should not be loaded. And in this case, we need our own, the Postgres repository type exclude filter. And that's more or less a class implementing or extending the standard annotation customizable type exclude filter. Spring naming is long but precise. And in that case, in the constructor, I get past the annotation itself, so I can extract metadata from there. And in this case, if in the annotation the repository's value was set, I will only load the repositories that was specified there. If I omit it, I will load all repositories within my application. And then some methods I need to override is use defaults filters. Yes, it's true. Please use the defaults also. And the most important method are the get default include and that get component includes. And these does control which beans get loaded in our case. So only our repositories are now loaded. And now we need even more annotations on our annotation. We annotated with at import auto configuration and override auto configuration because these annotations allow us to reuse existing auto configurations of Spring Boot. I assume everybody knows that the magic of Spring Boot is more or less providing you with multiple auto configurations. And to specify which auto configurations to load, Spring test or Spring Boot test looks at a specific place, and in that case it's metainf/spring/ name of your annotation .imports. Sorry. So there we specify all the auto configurations that our test slice loads, and there is such file for every existing test slice within the framework itself. And now we are nearly done. Just one more annotation. We need to configure the complete context ourselves a little bit more. That's at context configuration, which we can pass an initializer. And that initializer now does finally something. And in this case, we create our Postgres SQL container. We add an application listener who listens on close to stop the container. Then we start the container, and then we provide the relevant values into the environment so that our own JDBC template or data source that's created finds exactly that container that's registered here. And then for that specific use case, just one more annotation. We make the complete test transactional, so every changes that are done within our test are rollbacked later, and we don't need to create the database for every test from scratch. So that's a lot, right? But that's the ultimate thing you can do. That's the main point for building your own abstractions on top. And for example, the Spring Modulus project has some own slices, and that's the way they do it. And if you ask me, I would say only extend, compose, or create is last resort. There are so much batteries included. There's a slice for most of your use cases. Please reuse them first, and just if you reach the end of that, think about adding yourself. But if you have the case, do it. It will make your life so much easier to have some more meta concepts. Okay. And of course, we could talk about multiple more topics. For example, you could try out approval testing. That's a thing I know most from front-end frameworks, where you basically say, render my component, and oh, that should look like exactly that generated code into that file. But if you are in a legacy application, that may be a good fit for getting some tests, because you don't need to specify your own assertions. You just print something into a file, then you can change your code, and afterwards you look, the output should look the same, right? So you could try it. There's property-based testing, where the concept is kind of randomness. So you describe properties of your objects or your functions. For example, for FizzBuzz, every third element starts with fizz, and then that's the property that you express. And so you say for all numbers that are divisible by 3, it should start with fizz. And then this provide divisible by 3 generates random integers for every run. So that's a little bit like a combination, and in one of our projects we use this arbitraries extension which comes with jQuick for generating random data, like you've seen in the data faker or common slang examples before. So if you stumble across a problem that's good to express by properties, you can use that. And for a long time I said to my colleagues, I don't see any real world example for using property-based testing. And one colleague used it to validate that basically every string that's sent to his API produces at least a OK, because they wanted to accept any string. And because this library is very clever, it starts with an empty string and then some tabs and then some Arabic chars and some non-ASCII printable chars, and so you get a lot get thrown with stuff you never thought of yourself. And then there's more. So we could talk about test containers and using that. We could discuss to use or not to use mocks. We could discuss, do we want a test parameters, which means most unit tests, a few integration, and even less end-to-end tests, or do we want a test honeycomb, which means a few tests, unit tests, many integration tests, and a few end-to-end tests. There's a funny blog entry from Google, like they doing testing on the toilet to motivate people to write tests. It's 15 years old or 16 years old. Have a read. Maybe you find that a little bit funny too. There's an excellent blog post by Maciej where he writes his own extension, so you can extend your test to consume the log output of the test containers that were started for the test, which can be used for debugging purposes. And yeah, I think you can find more and more topics, and we could discuss about many topics. So to wrap it up, conclusion. Please read the documentation. Obvious, I think. Learn the basics. Obvious, you do it. But know some advanced stuff. And please be open-minded. Keep your eyes open. There is so much to discover in the testing or testing support space. If you see something that a library, utilities, or even concepts like this test mother concept, read it, try it out, find out for yourself if it helps or if it hurts you. And you can extend the included battery, but only extend it when it's necessary. Don't introduce technical complexity for the sake of introducing technical complexity, even in your tests. And the most important thing is, do whatever works in your context. So it's your application, you have to maintain it, and I think that applies for maybe everything that's said on conferences, because you should never do what a random person on stage tells you. Please do what works in your context. So that's from me. The slides are already available there. If you want to get in contact with me, because that's the last slot of the day, just choose your favorite contact point. Or if you see me at a conference, say hi. So thanks for patience, and I think we had at least a minute for questions or hints. Yes? Yeah? The question was if there are test containers for Kafka available. I don't know in my head everything, but some people say yes, and they are constantly Yeah.
Something like an embedded Kafka application.
Yeah, embedded Kafka should be, but test containers is constantly evolving and they are adding module for module. Okay, thanks. You can use the microphone.
What about application context runners? Did you ever use them or did you look into them?
I think the application context runners are should be used if you write your own auto configurations. If
yes,
I remember correctly.
I sort of have used it and also found it's quite useful when you have different configuration settings to start up.
Yeah, I've used them when I write my own auto configurations, but that's not so often.
Okay.
Yeah. Okay, thank you. Safe travels.